Hello everyone, welcome back. Today we are going to be examining Coulombs Law. So what basically is Coulombs Law? Coulombs Law examines the size or magnitude of the electrostatic force that one static point charge exerts on another static point charge. So he basically states that the electrostatic force is directly proportional to the product of the charges and inverse proportional to the square of the distance between them. And looking at it from point of view of an equation, we see that f of e equals k times q1 times q2 divided by, the whole thing is divided by r squared. K is Coulomb's law constant. It's always the same every point of the universe, as we have discussed in class. So it's 8.99 times 10 to the ninth newtons times meter per squared per coulomb squared. Q1 is Coulombic charge 1, Q2 is Coulombic charge 2, and R, of course, is the distance between the charges. So, let's first examine the quantitative relationships that we can infer from this law. Okay, so we said that the equation is f of e equals k Coulomb's law constant times q1 charge 1 times q2 charge 2 divided by r squared, which is of course the distance between them squared. So the first quantitative relationship that you need to know is the relationship between f of e, the electrostatic force, and that for any, in this case it could be any charge. Now as you remember correctly, f of v and q1, they're both in the numerator, so that means that they are directly proportional. So if we're to graph it, it would be a straight line simply going like that. And it doesn't matter which one it is. It could be f of e q1 versus f of e q2. They will always have pretty much the same graph because of the relationship that they have. Now, if we have to look at the relationship between f of e and k, okay, because remember it's the k is a constant, that would be what? That would be a straight line. So that means no matter what the electrostatic force is, the constant of course will always stay the same. That is of course called constant proportional. And the third relationship that we have to examine, of course, is the relationship between electrostatic force and, of course, R squared. That is a directly squared proportional relationship. And the graph, of course, is going to be going up like this and it's going to curve. So now that we know the proportionalities, and I hope you remember them from class, we're now going to go into a new flip book. And before we go into that, let's actually, do our first problem. So going back to the PowerPoint presentation, we simply see over here that, let's say we have the following problem. We have to calculate the electrostatic force of a positive 2 Coulomb sphere that it has on a negative 3 Coulomb sphere at a distance of 1 meter. So let's draw the problem so we understand exactly what they want from us. So let's say it's hanging by a string. We have one sphere right here. That's going to be negative 2 coulombs. And we have another sphere right here. And that's going to be positive 3 coulombs. And these two are separated by a distance of 1 meter. Notice how both of these charges are static, meaning they're not moving. So we have to calculate now the force between these two charges. So we're going to go to Coulomb's law. So it's going to be f of e equals k times q1 times q2 divided by r squared. And we are going to plug our numbers in. In this case, K, we said it's always constant and never changes. It's straight in your reference table. That's going to be 8.99, which is very close to 9, times 10 to the ninth. That's going to be newtons times meters squared per coulomb squared times the first charge, which is going to be -2 coulombs, times the second charge, which is Coulombic 1 charge 1 and Coulombic charge 2. So that is going to be now times +3 coulombs. And we're going to divide the whole thing by the distance between them, which is 1 meter, and of course that is going to be squared. So, so coulombs times coulombs is coulombs squared, so these units cancel out. And meters squared divided by meters squared, that those units cancel out. So the only thing that remains now, once we have the units, which is only of newtons, once we have the units, we can now go ahead and we can multiply. 8.99 times 10 to the ninth times -2 times +3. If we put in a calculator, we're going to see that it's going to be -5.39 times 10 to the 10th power. And we're going to divide it, of course, by 1 squared. It's going to be 1. So our answer is going to be -5.39 times 10 to the 10th. And the units, of course, are going to be newtons. Now, the negative charge over here, in this case, it's not directionality, but rather it means that the forces between them, it is going to be attractive, not repulsive. And you can very easily see this. This is negative, that's positive. It is exactly as we would expect. It's their attractive forces. So, going back to a diagram here, we see that -2 exerts a force of -5.39 times 10 to the 10th newtons on the +3 coulomb sphere, and the same exact force the +3 coulomb sphere will exert on the -2 coulomb sphere, and that's going to be again -5.39 times 10 to the 10th newtons, because Newton's third law, for every action, there's an equal and opposite reaction. Now, the only thing I have to add to this is be careful. Sometimes they may not give you Coulombic charges, but rather they might say if this has one electron and this is another electron, to calculate the electrostatic force. In this case, you have to remember that an electron will carry an elementary charge of 1.6 times 10 to the -19 coulombs, as we have discussed in a previous video, and that of course is going to be negative. So for Q1, if you have one electron here, separated by a distance of 1 meter, it would be, you would have to put -1.6 times the -19 coulombs here, -1.6 times 10 to the -19 coulombs here, multiply this by Coulombs law constant, and then of course divide it by the distance between them squared, and you would get the answer. So in case they don't give you actual Coulombic charges, please read the problem carefully and make sure you can infer to the number of elementary charges that they are referring to. Thank you.